Okay, so this is the electrical panel of a late model Eclipse built like after 2000. This panel is about 24 years old, and we're going to talk about upgrading the servo drives right here. The original drives looked like this, black drives. There was X and Y and Z. The Z is different internally than X and Y. So this is the new drives. They're blue. There's an adapter plate that needs to be installed in the electrical panel because these drives are much smaller than these drives. There's a comparison. Okay. So these drives are programmable. This little dongle right here is for programming the drive with this cable right here. So whenever you get an upgrade to these drives, you'll get a cable like this that needs to be left inside the electrical panel for future service. Now, the wiring is a bit different on these drives, so let's kind of go through that. There's this area right here. You can see that there's a number of blocks here that say 0 volts. You can see that there's a number of them that are empty now. Okay, we don't need as many 0 volt lines in this case, and 3 of the lines get moved, and we'll talk about that. These are your control lines right here. This is a 0 volt line, and then this other line here, which is blue, it's hard to tell, it's a dark blue, is the control line. This black line is a 0 volts, and this white line is the enable line. These unplug by pushing down on this little tab and pulling out, and they unplug. So these are the Hall effects. There's a 0 volt line here, and then there's a UV and W Hall sensor. These lines go over through this cable track and up to the respective location for, there's the Z right there, and there's the X right there, and in behind back here is the Y lines and the Hall effects. You can see they're labeled, and the label on the wire matches the label on the terminal block. Okay, so that's the Hall effect line. As I said, there's a 0 volt and a control line right here. So 1 is the control line and 16 is the 0 volt line. They run over here, down here, and to the ICM 1100. You see this says motor command Z, and that's the blue line. And then there's a ground connection, and that's the 0 volt line. It says ground Z on it, and so that ground Z goes over here to 16, number 16 on this connector, J5. And then the blue line goes to 1 on the J5. Alright, this 0 volt line here, which is number 2, goes over to the control panel. In fact, I think it goes this way, and it goes all the way over here, and it goes in here. And Z is in the back, and Y is in the middle, and X is up front. So this same pattern of wires is repeated for each drive. Now, the power for the drive comes on these two lines. This is the J3 connector, power. You can see that right there. And it runs over here and runs to this block right here, which has got 48 volts DC coming in on this side, and then getting split out into X on the front level, Y in the middle level, Z in the back level. All the reds go on the top terminal block, blacks on the bottom, and they feed the Z and the Y and the X lines. Alright, now the power goes in here on these two wires, comes out on these 4 wires. Well, technically this is a ground wire, and then you've got 3 phases on your motor. This is the J2 connector. It says motor on it. So these wires run up here, they run in this cable track, and they run over here to Z, X, and Y back there behind X. And then they plug into these connectors up here, which go up to the motors. All right. They're all identical wiring pattern. You can see each label says this one starts with Z for the Z, this one starts for Y for the Y, and this one starts for X for the X. I've labeled the positions on the adapter panel, X, Y, and Z, and the adapter panel does need to go in a certain direction, and it mounts in the original 3 holes for mounting the original 3 drives. Alright, to take the covers off these wireways, you push over and tilt out, and then the cover comes right off. So push over, tilt out. This one will push up and tilt it out, and now we can take all these wires out or put all the wires in, whichever we want to do. You will need a small screwdriver. I recommend a couple screwdrivers. I got these at Menards. You can see that one has a 5/64 tip and the other one has a 3/32 tip, and you might want one with an 1/8 inch tip. So if we're going to take the Z and the X, there's Z right here. So if we're going to take the Z out, we just disconnect, get in here with our little screwdriver, loosen these screws, pull the wires out. And then you can push on the little clip on the top. See that little clip? And so that is the wire for the Z. To put it back in, you just do the opposite. Okay. So these are current state-of-the-art drives. Upgrading your old drives, which are 25 to 30-year-old technology. These drives work great. I've got this one partially some of the wires partially removed here. I've got the Hall effects removed. I've got the power wires removed. You can see up here, the Hall effects go here, power wires over here. Alright, now the white wire on these guys. Sometimes this is also violet or pink, but this wire from position 3 on the J5 connector goes over to this relay back into these connectors back here underneath this 14, 10, 11, and 12. So this is X, Y, and Z. Okay, and those wires go through this relay, which is emergency stop relay, and they come out on these pink wires. Sometimes they're white, sometimes they're pink, sometimes they're violet. And these wires run through this cable track down here and go to the ICM 2900 or the motion controller, whatever flavor that is. So you have amp enable Z, amp enable Y, and amp enable X. If you can see those labels. Okay. So these are Phillips head screws. Number 2 Phillips screwdriver works good on those. Alright, thank you. All of the control lines removed. Connector J4 and J5 and J2. So J2 remembers the motor power, and it goes up here. Z, X, and Y. J4 connector is the Hall effects, and there's Z and X and Y back here. And then J5 is your control lines, and they were in the 0 volts on this side, and down here on the 2900 your motor command lines. And each one of those wire assemblies looks something like that. There's the control line one, and there's the power line, and there's a Hall effect line. Little short black one goes to 0 volts on this side. Okay, and there's one for each axis of the motor. So now I've removed the power lines, which were feeding out of this distribution block, and there's what the power line assembly looks like. So we've got all of the wiring removed from this machine, and then to take a drive out, you basically take a Phillips screwdriver and you take one screw out from one side. Let's see how I do this with one hand. Then you can just loosen this screw, and the drive essentially falls out. So there's your drive. And you just repeat that to take the other 2 drives out. There we have all the drives removed. Now, when you take the drives out, make sure you label the drives somehow, and so you keep them in order of how they were in the machine, because they're programmed differently. Now, to take this back panel out, you're gonna need a 5/64 Allen screw. I'll do that now and come back to you. Alright, so we've got the adapter panel removed, and these are the original mounting holes for the original drives. There's the adapter plate down there. Okay. Alright, so this is what a complete upgrade kit looks like. Power wires, high voltage power wire assembly, individual motor power assemblies, one for Z, Y, and X, Hall effect sensor wires, programming cable, control cable for each line with the programming cable connector, one for each axis, Z, Y, X, the adapter plate with the 3 drives mounted to it, and the mounting screws to mount the adapter plate into the machine. And each drive is labeled for the motor and the position and programmed accordingly. Alright, so that's the whole kit. So one more thing, these are the tools, the specialty tools that you need to work with these drives. This is a tool for crimping on the small crimp sockets. This is the extractor tool for those sockets. And this is the tool for crimping on the large wire connector sockets, and that's the special removal tool for that. Crimping tool with a hex die. You can use a square die, but I prefer the hex die for the wire ferrules. Different sizes: 26 gauge, 24 gauge, 22 gauge, 20 gauge, and 16 gauge. And then this is the label maker for the shrink tube labels. It will also make tape labels. So these are the specialty tools for working in the electrical panel.